Physical science students, this is the beginning of week 7 of COVID High School. If we had a mascot for COVID High School, what would it be? Like the COVID Cobras? The COVID mask wearers? I don't know. I'm tired of COVID High School. I want to go back to Parma High School. Anyway, so start of week 7. We have this entire week that I'm going to finish lecturing on atomic structure. And then the following week, the week 8, May 18th through the 22nd. May 18th is the anniversary of Mount St. Helens blowing up. So there's that. None of you were alive when it happened. I was just a young whippersnapper. Anyway, that's finals week. And I'm going to tell you that the end of this week, I will be emailing some of you and giving you some very good news about the final. Just keep that in mind. So, first thing I want to do is I want to share my screen. I want to share my iPad. And see if we can do this. It's Mother's Day, by the way. I just had a visit from one child and the other one called me. They apparently both still love me, so that's good. I'm trying to share my iPad so that I can draw some stuff on here. A lot of the quizzes that are this week talk about, do you know how atoms are represented? We did that the last week. If you want to rewatch the video entitled Isotopes, that wouldn't be a bad idea. But I'm going to review some of that. So let's say, just as a review, if I can get my whiteboard on my iPad to work, my iPad's about, oh, that's a drawing I did for integrated science. That's somebody running down a mountainside that is covered in lava. You don't need to know about that. Anywho, let's create a new whiteboard. All right, so let's start with this. Let's write. Let's go ahead and make that. If I'm talking about this isotope, now a lot of times isotope and atom can be used interchangeably. An atom is the smallest particle of an element that can still be identified as that element. The periodic table represents an average of atoms that are found in nature, an average of isotopes that are found in nature. So if I say the isotope sulfur 32, which is how we would say this, I could also say atom 32, but I want you to know that I'm specifically talking about I'm telling you the mass number of this isotope. Okay, not all sulfur atoms have this mass number. They all have the same atomic number, but they don't have the same mass number. So if I were to give you this, and I could ask you some different questions. Question number 1, and I'm going to ask these questions, and then I'm going to have you pause the video and answer them. Okay, and then you can check how you answered them. So question number one, what is the atomic number of this isotope? Question number 2, how many neutrons would there be in this isotope? And question number 3, how many protons would be in this isotope? So question number 1, what is the atomic number of sulfur 32? That's how you would say this, sulfur 32. Number 2, how many neutrons would be in an atom of sulfur 32 or an isotope of sulfur 32. And number 3, how many protons would there be? So pause it, gather what information you can, and here are the answers. So number 1, the atomic number of sulfur 32, the only way we can get the atomic number is to go to the periodic table. Find sulfur. Sulfur is one of the 5 main group nonmetals that we've talked about. And you look at sulfur, and it tells you that sulfur is sulfur because it has an atomic number of 16. That the whole number, the number without decimals, on your periodic table is the atomic number. The entire periodic table is set up by atomic number. Remember that. It's organized by atomic number. It goes from 1 hydrogen clear through 92, which is uranium. There's others past that, but those are synthetic or created in the lab. 1 through 92 are the ones that are found naturally. So that's question number 1. That's the atomic number. Number 2, how many neutrons would there be? So we take 32, which is the mass number. By definition, mass number is number of protons and neutrons. And we take out how many are protons. We do some fancy math. We find out that this atom also happens to have 16 neutrons. 16 and 16 is 32. The atomic number plus its number of neutrons is going to give you this, the mass number. Number 3, how many protons are there? That's easy because once we've identified what its atomic number is, it's by definition the same thing as the number of protons. So there's 16 protons. Okay, let's do another one. Let's erase this. Let me give you this little guy. Find him on the periodic table. He is an alkaline earth metal. Number 1, tell me what its mass number is. Number 2, tell me the number of protons. And number 3, tell me the number of neutrons. Pause it if you need to, and then you can start it again and I'll give you the answers. Had to get a drink of water. Okay, so beryllium 9. This is written a little bit differently than the other one with sulfur. Another way you can write this is beryllium 9, the dash there. Both of these are representing the same isotope. Beryllium is beryllium because of its number of protons or its atomic number. So let's go ahead and answer number 2 first. The number of protons, if you look up beryllium on the periodic table, it is number 4. It has 4 protons. Number of protons, atomic number, el mismo. The mass number, should have put that on here. The mass number is told to you. I told you the mass number. The upper left-hand corner, remember, surrounding the symbol of any element, the upper left-hand corner is always designated for the mass number. So the mass number is going to be 9. Remember that mass number by definition is the number of protons plus neutrons. 4 of them have to be protons because it's beryllium. If it had any other number of protons, it wouldn't be beryllium. If it had 3, lithium. If it had 1 extra, 5, that would be boron, okay? So 4 protons is always going to be beryllium. So if I have 9 protons and neutrons, which is what my mass number tells me, and 4 of them have to be protons, 5 are left to be the number of neutrons. All right? And again, I'm doing these. Some of you guys are going, got it, Mrs. K, we had it the last time, but a review doesn't hurt. And this is what a lot of your quizzes are covering. So let me give you another one more. Let's go to the main group metals. Tell me number of protons, number of neutrons, and let's try something different. Number of electrons. See if you can tell that. Pause it if you need to. Find aluminum, again, main group nonmetal. So it's going to be in that tall group of families, the 6 families, but to the left of the zigzag line. So now that you've had time to pause it and do it, let's do this. Number 1, number of protons. Aluminum is aluminum because of its, where are you at, aluminum? Because of its 13 protons. Everything in the whole freaking universe that has 13 protons is going to be aluminum. So the number of protons is 13. Number of neutrons is going to be 26. Remember, that's our mass number that I gave you in the upper left-hand corner, minus the number of protons, and we end up with 13. Again, this is not always the case. You don't always have the same number of protons and neutrons. When you do, the atom tends to be more stable, but that's not always the case. It is hardly ever the case when we get into the big ones, The smaller ones that are found, in the first 1 to 2, 3 periods, it'll be pretty close. And then the number of electrons, well, remember that a proton has a charge of +1. If I have 13 of them, I'm going to have a total charge of +13. In order for my overall charge to be +3, here we are, +3, I have to have 10 electrons to make that true. If you got that, super. That's our next video, all right? But let me show you how you could do this maybe a little bit more visually for the visual type learners. Let's take all the protons for aluminum. You guys are going to see this again, so don't worry. Let's take all the protons for aluminum. Let's take them out of the nucleus and let's stretch them out in a straight line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's close them in there. All right. That represents what the nucleus, the charge that the nucleus has. But we know that the whole atom isn't just the nucleus. We have those electrons flying around outside. Remember, Rutherford got them out of the nucleus, and Bohr put them into energy levels, and then Schrodinger and Heisenberg said, well, we don't really know where they are. Yeah. Anyway, for every electron that I have, it's going to cancel out the charge of a proton. So if this were the case right now, my 13 protons that make aluminum, if it had 1 electron, we would have a charge right now of +12. We have 12 protons that aren't canceled out. There's nothing that's +12, so we got to keep going. So I told you on the last one that if the charge was +3, we would have 10 electrons, right? So let's put 10 in and see what happens. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 that I said. What do we have left over? What's left over? There are 3 protons that do not have an electron to cancel them out. So the atom as a whole, go back to black here. Here's my nucleus of protons. The atom as a whole with 10 electrons this is what it's going to look like. I keep pointing with my pencil that you can't see. This is what it would look like. 13 on the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total. This atom is going to have a charge of +3. And guess what? I'm not just making this up. That's what aluminum does. He typically gives 3 electrons away so that he can be stable. We're going to talk about that later. All right, let's go on to some new notes. Hopefully that's going to help with your quizzes coming up, because I give you questions like that I want you to answer. Now let me share my PowerPoint with you. Let's talk about hydrogen. Hydrogen's cool. Hydrogen played a pretty big role in, oops. Oh yeah, I did. Oh, poopies. I mean, shoot. Let me go back to the screen share. Okay, hydrogen played a big role in World War II and the reason that we won it. So, but let's talk about hydrogen. Hydrogen, just like other elements, has some isotopes that are found in nature. I'm going to draw these isotopes for you on this thing. I'm hoping, oh, let's do this one in red. You know what? I don't want to do that because I don't do well drawing on this. I'll do it on my iPad later. Okay. Hydrogen has 3 naturally occurring isotopes. Hydrogen 1. Okay. What would the model for hydrogen 1 look like? What does this number tell us? This tells us that its mass number is 1. All right? That means it has a total of 1 protons and neutrons. The mass number is a sum of protons and neutrons. If the mass number is 1, that 1 has to be a proton. All right? Oops. The proton in this particular isotope of hydrogen, there's going to be 1 proton, there's going to be 0 neutrons. Literally, this is simply, let's make protium red. This is simply, you know, I'm getting tired of this not working. And a proton in the nucleus with an electron floating around outside. That's the Bohr model. That is a model that I would draw of the hydrogen isotope called hydrogen 1. Hydrogen is a special case because it is the only element whose isotopes have special names. It is called protium, pro meaning 1. It has it has a mass number of 1. It has an atomic number of 1 as well. Hydrogen is hydrogen because it has 1 proton in the nucleus. Now, let's go to the other isotope, hydrogen 2. Hydrogen 2 would look like, and I want to change colors. Hydrogen 2 would still have 1 proton in the nucleus, but it would also have a neutron, a proton and a neutron in the nucleus. And then there's no charge. See, I don't have any charge to the right of this, so it's going to have its little electron out there. But this is a proton and a neutron. You add those together, and that is your mass number. So if I were to ask you, number of protons, 1 has to be. It wouldn't be hydrogen if it didn't have 1 proton. But since its mass number is 2, it has to have a neutron as well. We can't just add another proton to make this be true. If we added another proton, we wouldn't have hydrogen. We would have helium, right? We call this little guy, instead of just being hydrogen 2, it has its own special name. It's called deuterium. This, and I'm not going to go through this whole story, I would if we were in person, but this right here, the deuterium isotope, goes into making something called heavy water, and heavy water is very important in nuclear reactors when you're trying to make an atomic bomb. And let's just say that parachuting scientists saved World War II. We would all be communists had it not been for parachuting scientists that knew about heavy water. When we're in chemistry, when you guys are in chemistry, I'll tell you that whole story. It's really fascinating. Anywho, let's go on to the third isotope of hydrogen. Hardly any of these are, this isotope is not very abundant. But it's hydrogen 3, so what's it going to look like? It's going to have, let's change to red. Nope, I already did red. Let's change to purple. All right, so we are going to have 1 proton, right? It has to have 1 proton, so it'll be hydrogen, and it's going to have 2 neutrons in the nucleus. Sorry, I'm doing this with my mouse. And then it's neutral. I didn't tell you it had a charge, so it's going to have that little electron. So these are the Bohr models of the 3 isotopes of hydrogen. These are one way to represent it. Remember, we could also represent it like this. Protium. Hey, where's my little pen? Protium could be represented that way. Deuterium could be represented that way. And tritium could be represented that way. And that's what we call this one. It still has its 1 proton, but 2 neutrons. And it's called tritium. So the special case of hydrogen, they all have the same atomic number, 1, because they all have 1 proton, but the one that has no neutrons is called protium, the one that has 2 neutrons is called deuterium, and the one that has 3 neutrons is called tritium. And I'm going to stop there for today because explaining the decimal number on the periodic table, I got to think about how I'm going to do that via a Zoom. So I guess I'll see you guys on the other side.